This presentation is on genetic mutations, specifically the CAG trinucleotide repeat as seen in Huntington's, presented by Michaela Cordingley. Genetic mutations. A genetic mutation is a permanent alteration in the DNA sequence that makes up a gene. One such mutation is called a CAG trinucleotide repeat. As the name suggests, it is a mutation in which a trinucleotide segment made up of large amounts of cytosine, adenine, and guanine, appearing multiple times in a row, repeats in a gene in numbers that exceed the normal stable limit. This mutation can be found on the HTT gene located on the P arm of the number 4 chromosome. Mutagen that causes the mutation. The HTT gene provides instructions for making a protein called Huntington. The exact function of this protein is currently unknown. However, it appears to play an important role in the neurons of the brain and is essential for normal development before birth. While the brain has the highest concentration of this protein, it can also be found in a variety of other bodily tissues. Within the cell, it is speculated that it is involved in chemical signaling and protecting the cell from self-destruction. The CAG trinucleotide repeat is seen in a region of the HTT gene, resulting in an autosomal dominant disease called Huntington's, also known as Huntington's chorea. In people without this disease, the trinucleotide section usually only appears 10 to 35 times. However, in people with Huntington's, the section is repeated anywhere between 36 to 120 times. Individuals with a repeat between 36 to 40 have a lesser chance of being affected, but run the risk of having their children be affected, while those with over 40 repeats almost always develop the disorder. Effects on gene function and protein synthesis. An increase in the length of the CAG segment caused by the mutation on the non-coding strand of DNA causes an elongated complementary mRNA strand. This results in the production of an abnormally long version of the Huntington protein. This elongated protein is lysed into smaller toxic fragments that bind together and accumulate in the brain neurons, disrupting normal cell function. This dysfunction and eventual death of the neurons in the brain causes Huntington's to be a progressive and deadly brain disorder. As this disease is autosomal dominant, the mutated HTT gene is passed from one generation to the next. As this happens, the CAG trinucleotide repeat often increases in size. The increase in repeats is associated with earlier onset of symptoms. Huntington's symptoms. The most common symptoms of Huntington's are uncontrolled movements, like jerking or twitching, also known as chorea, emotional issues, and a loss of cognition. The most common form of the disease, adult-onset Huntington's, usually appears in the early 30s or 40s. Early symptoms include irritability, depression, small involuntary movements, poor coordination, and trouble learning new things. However, as the disease progresses, individuals have trouble walking, speaking, and swallowing, as well as having a change in personality. Those with this disease usually live about 15 to 20 years after symptoms begin. Huntington's treatment options. Currently, there is no cure for Huntington's, but the symptoms can be managed or alleviated as a way to improve quality of life. Medication, such as antidepressants, can be given to prevent depression, mood swings, and tetrabenazine is prescribed to lessen involuntary movements. Speech therapy can also improve communication and ease swallowing. While there is no cure right now, researchers remain hopeful as technology advances and studies begin to show promise. And that's it for my slideshow on the CAG trinucleotide repeat as seen in Huntington's. I hope you enjoyed.